Children, next question. Portx mixture. Okay. Portx mixture is a mixture of copper sulfate and next potash. So here that is give the four option: pyridine, rochelle salt, lime, sodium oxide. So first pyridine, we know the formula. So what is the pyridine formula? That is C5H5N. Pyridine C5H5N. Rochelle salt mean that is potassium, okay, sodium tartrate, tetrahydrate. This is a chemical formula for rochelle salt. So lime, that is calcium hydroxide, CaOH twice, and sodium oxide, Na2O. Okay, children. So now first what are the that is the option given. Now writing the formula. So first we know what is the Portx mixture. Portx mixture means it is the mixture of copper sulfate and lime. Okay. So this one that is used as a fungicides. It is used for fungicide. So copper sulfate and lime. Okay. So CuSO4, copper sulfate and lime. So lime formula calcium hydroxide. Okay. So this mixture is known as Portx mixture. So what is the correct option? That is the third one. That is lime. Okay. Next question. On strong heating, AgNO3 produces the gases. So here that is the option is given. So strong heating produces the gas. What are the gas? Okay. So now AgNO3. So here this another one word question. Lunar caustic. So lunar caustic, the chemical formula is AgNO3. Okay, children. So now write the equation. AgNO3. Strongly heating. So heating temperature 723 Kelvin to use AgNO2. Okay, plus O2. So now balance the equation. So 3 2s are 6. Here 2. Okay. So next again this AgNO2 at 980 Kelvin to use Ag plus NO2, nitrogen dioxide gas. Okay. So here, so what are the gases? Oxygen gas. Okay. So here NO2 gas. So now see the option NO2, NO, NOO2, N2O, NO, NO2 and O2. So what is the correct option? So now NO2 and O2. So the answer is fourth option, NO2 and O2. Okay, next question, children. Magnetic moment 2.84 this PM. Okay, Bohr magneton is given by. So four option is given. So read the question. Magnetic moment value is 2.84. So this 2.84 is relevant which, that is the ionic state of transition element. Which one is? It is matched. Okay. So for this type of question we are going to answer mean. First we know the magnetic moment calculation. Okay. That is we must know the formula. So mu is spin only magnetic moment. Okay. Equal to N, that is the root of N into N plus 2 Bm, Bohr magneton. This is the formula. Okay. So next one. Now that is the number of unpaired electron. Writing here. So number of unpaired electron. Okay. Now 1. So now that is the Bohr magneton value is, that is 1.73. Now number of unpaired electron it is 2, that is 2.84. Number of unpaired electron 3, that is 3.87. Number of unpaired electron 4, 4.90. Number of unpaired electron 5, 5.92. Children, this is the trick. So keep in your mind. So number of unpaired electron 1, 1.7. Unpaired electron 2, 2.84. So for such a type of question, now just to find out how many number of unpaired electron. So you can answer it this very quickly. Okay. So here cobalt, nickel, titanium, chromium given. So write the series. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and the zinc. Children, why I am writing again and again mean, if whenever you have that is see this video, you can memorize very quickly. Okay children, so for each and every time I am writing again and again, so you must follow this. So just to practice well, so automatically you can write direct atomic number. Okay, so now cobalt here. Okay, so now 21, 22, 23, 24, 25, 26, 27. Okay, nickel 28, titanium 22, chromium 24. Okay, so now write that is the find out the number of unpaired electron. Cobalt 27. So 3d7, 4s2. So 2 plus. So 3d7. So it's cobalt plus 2, 3d7. So how many unpaired electrons? See here, how did you have calculated? It's a d orbital, that is a 5 orientation. Okay, 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Here number of unpaired electron, that is 3. Number of unpaired electron 3. So 3 means what about 3.87 for this. Okay, 3.87. Next nickel 28. So 28, 3d8, 4s2. Okay children, so now nickel plus 2. So plus 2 remaining. So nickel plus 2. So 3d8. So 3d8 means, so to calculate the number of unpaired electrons here. Of unpaired electron, that is 2. Okay, number of unpaired electron is 2. So what about this? 2.84 for this one. Next titanium. Titanium 22. So 3d2, 4s2. Okay, so 3 plus so 1. So titanium, that is 3 plus 3d1. So number of unpaired electron 1. So 1 means that is 1.73. Next to chromium 24. So 3d4 chromium, 3d4 4s2. So here plus 2. So 3d4 only. Okay. So here number of unpaired electron 4. So 4 means that is 4.90. Okay children. Now come to the question. Magnetic moment 2.84. So first one 3.8, second one 2.84, 1.7. So what is the correct option? This nickel is the correct option. Ni2 plus. Children, for such a type of question, they are asking the magnetic moment mean. First we know the formula. Mu is equal to root of n into n plus 2. Bm denoted as the unit, that is Bohr magneton. Okay, but I am that is here I am that is never done the calculation because I give the clue here. Okay, this values alone, that is mu s values alone writing here. So we must know first to find out number of unpaired electron. So 1 means this value, 2, 3, 4, 5. This keep in your mind. Okay, and how did you calculate the number of unpaired electron? We know the atomic number. So some that is element given the ionic formation. So remove this electron from that to calculate the number of unpaired electron. Alright, next question. 4 successive members of the first series of transition metal listed below. This is transition metal Fe, nickel, cobalt and copper. For which one of them the standard electrode potential value has positive? Okay, So once again, for which one of them the standard electrode potential, that is E0, concept M2 plus to M, okay, value has the positive sign, that is very important, positive sign. So here some, that is the transition series is given. So among this, which one is the positive values of the EMF? So first is here standard electrode potential. This topic that is already saw the previous video. So standard electrode potential means is the value, okay, of the standard EMF of the cell. Okay, we know the condition, that is 1 atmospheric pressure and 298 Kelvin. That means at 25 degrees Celsius, hydrogen is the standard one. So now this standard electrode potential, that is used to measure the, that is the oxidizing and reducing power of element is measured in terms of, that is the standard electrode potential. So we know about something, the standard electrode potential. Here question is, which element has the positive sign? Okay, so now I am writing, the children see this, that is the tabular column. So writing M2 plus to M, that means that is again 2 electron, okay, and to use, that is the titanium. So titanium 2 plus 2 electron to use titanium. Now the standard electrode potential value is minus 1.63. Same way titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. I am writing this first series. The question is first series. So I am writing the series as well as I am writing the standard electrode potential. Here, see here, all the values are negative except this. So what is the metal? That is the copper. Okay, so here plus 0.34 volt. So see the question, which one of them the standard electrode potential M2 plus 2M value has positive sign. So what is the correct option? This the fourth one is the correct option, because the remaining all the element, the EMF value standard, that is the electrode potential value is negative. For example, Fe minus 0.4, nickel 0.2, that is a 2,3, cobalt minus 0.28, but copper only, that is the positive sign, the value is plus 0.34 volt. Next question, among potassium, calcium, iron and zinc, the element which can form more than one binary compound with chlorine. Once again, among potassium, calcium, iron and zinc, the element which can form more than one binary compound. Binary means that is the 2. Okay, it exists to 2 formula. Now see here, first we know the alkali metals. What is alkali metal? That is a lithium, sodium, potassium, rubidium, cesium and francium. This is the alkali metals. Now potassium is the alkali metal. Okay, that is NS1 configuration. And next, beryllium, magnesium, calcium, strontium, barium and radium. This one for NS2 configuration. So for this one, this group, okay. Now first group, here first group, this one for second group. So first group alkali metal, this one alkaline. This everything you know very well, children, just a recall, alkaline earth metal. Okay, so what about the oxidation state? This one for +1 oxidation state, this one for +2 oxidation state. Okay, so here calcium, so here that is the +2 oxidation state, calcium. Okay, so next one here iron, that is oxidation state, iron as well as zinc, this both also transition element. Okay, so now the iron oxidation state, that is Fe. Okay, so now this one for transition element you know very well. This one oxidation state is +2, +3. Okay, so +2 means ferrous, ferric you know very well. Okay, so next one +4 as well as +6. And next zinc, that is the oxidation state only, that is the +2 oxidation state. So now take this potassium, it will combine with the chlorine. So what is the molecular formula? KCl. Any other possible? KCl2, KCl3, it is not possible. So next take the calcium. So CaCl2. Okay, so but in that is the iron, it exists FeCl2, FeCl3. Okay, so as well as this one 4 as well as 6 also. But in zinc, that is ZnCl2, zinc chloride, it exists as zinc chloride molecules only. So see the question, more than one compound. So which one is the correct option? That is the correct answer. So among this, now we select the correct option is, that is iron, because it exists more than one compound, ferrous chloride as well as ferric chloride. Okay children, so now +2 and +3 oxidation state. So now it that is produce more than one compound. Children, next question. Atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. In which group would it be placed? Okay, for this electronic configuration of the particular element is present in which group? Can you understand the question, children? Once again, atom has electronic configuration this much. In which group would it be placed? Okay, so first is here. So what is the way to, that is the find out is very easily mean. Now to underline this outer valence electron, 3d3 4s2. So here d orbital. So now to identify this is a transition element. Okay, 3d3 4s2. So now transition element 3d3 4s2. Now to find out the atomic number. See here that is the 10. Okay, so this one 8, this one 5. So totally 23. So atomic number is equal to 23. 23. So atomic number 23 means what about the element? So now see the series: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, cobalt. So now 21, 22, 23. So now 23. So now you find out the element, atom. Now you have guessed it, that is the vanadium. So here question is group number. Okay, so in the periodic table, this is the pattern. This is a periodic table. Okay, so here group number 1 as well as 2, it is present here. Okay, so here this is the transition element, that is the 10 series is present. So first one scandium, titanium and vanadium. So 1, 2, 3, 4 and 5. So what about the group number for vanadium? That is the 5th group. Okay, maybe now if they are asking the period number. Okay, so period number mean what about the period number? This one for first hydrogen, lithium, okay, sodium, potassium. So 1, 2, 3, 4. So this one 4th period and group wise 5th. Okay, so now the question here only group they are asking. So now vanadium, from this electronic configuration, first find out the atomic number. So relevant element, that is we must select. So next one, draw the periodic table, so and find the position in other group as well as period. Okay, so group means it move from left to right. Okay, so group, that is a top to bottom period, that is left to right. Okay, so now vanadium, it is present in, that is the fifth. So what about the correct answer? So option first one, so fifth. So this vanadium element, it is present in the fifth group. Aqueous. Question number 14, children. The aqueous solution containing which one of the following ions will be colorless? Okay, the question is colorless substance. So here, let us give some option. So among this, which one is, it is colorless? So now the transition element, that is maximum, it is colored substance. Okay, if it is colored substance, mean it is that is assumption as it contain, that is unpaired electrons. If the element, especially in transition element, that is no unpaired electron, it is colorless. This is the concept, children. It contain unpaired electron, it is colored. No unpaired electron, it is colorless. So no unpaired electron means d orbitals, whether it is 0 or d orbital 10. For such a condition, the element is colorless. So based on this, we know, that is find out the correct option. Okay, so scandium 3 plus. Scandium, that is a 3 plus mean scandium atomic number, scandium. Okay, so 3d1, 4s2. So now Sc, that is the plus 3. So 3 electron, it is last. So now 3d orbital 0 and 4s orbital also 0. Okay, for scandium 3 plus category. Okay, next take the Fe plus 2. Where is Fe? Here 3d6, 4s2. Fe 3d6, 4s2. Question Fe plus 2. So 3d6. So how many unpaired electron? Number of unpaired electron, it is 4. Okay, unpaired electron 4. So the substance is colored. Next, titanium 3 plus. So 3 plus titanium, 3d2, 4s2. 2 plus 1, 3, it is last. So 3d1. So number of unpaired electron is 1. So it is colored. And next, Mn plus 2. Manganese, that is 3d5, 4s2. Okay, so Mn plus 2. So 3d5. So what is the number of unpaired electron? Number of unpaired electron, it is 5. So see here 3d0. So it is colorless. Okay, colorless. Based on unpaired electron. Okay, so here unpaired electron 4. So it is colored substance. Colored. Here number of unpaired electron 1. It is colored. Okay, here unpaired electron 5. It is colored. Now see the question. The aqueous solution, whether it is in metal or in ionic state. So aqueous solution containing which one of the following ions will be colorless? Children, I hope you can understand this question is very well. Okay, so now 3d0, 4s0 is a colorless. For here, that is Sc3 plus. So what is the correct option? That is the first one, that is Sc, that is the 3 plus. This is the last question. Formation of colored ions is possible when the compounds contain. This question is based on the previous question number 14. Okay, so you can find the answer is very easily. So once again I read the question. Formation of colored ion is possible when the compounds contain. When that is I already told, D block element, maximum it is the colored substance. Why it is colored substance? It contains unpaired electrons. Okay, if that is d orbital is 0 or d10 configuration, it is a colorless substance. So read the option here. Paired electron, lone pair of electron, none of the above. So what is the correct option, children? Unpaired electron. So the compounds are, it is colored in, that is the transition elements. So the correct option is unpaired electrons. Children, I hope you can that is understand all the question is that is easily. So thank you for watching all the previous videos also. So this one also have utilized in the proper way and take the notes. Thank you, children.